all, welcome you all faculties and research scholars from various colleges for 5 days FDP on electric vehicles designed to product development. It's my proud privilege to welcome and introduce our today's guest speaker, Mr. Ashar Ahmed. Mr. Ahmed has completed his BE in mechatronics, robotics, and automation engineering from SRM University. Sir has wide research experience in renewable energy and e-mobility sector. Sir is a recipient of Young Scientist Award in 2021 from the Innovation Solution Laboratories for his valuable contribution to the technology and ecosystem development in India. Sir is a co-founder of and director for the Skill Development Entrepreneurship. He is also co-founder director for Skill Development and Entrepreneurship, as well as director for EV for India. EV for India is an electric vehicle awareness initiative by Skillshark EduTech. Its main aim is to foster the adoption of electric vehicles in India by strategic collaboration with the institutions and government bodies. He has represented India in EV sector for various national and international conferences and conclaves across the globe. He has judged technical events across the India. Sir has been invited as a speaker and expert and guest speaker for wide number of engineering cum research institutions, including IITs and NITs. Presently, Sir is contributing as a skill development director for Skillshark EduTech. I am indeed honored to welcome Mr. Ahmed for this third day's first session. Once again, I would like to give him warm welcome and I request him to start the today's session. Over to you, sir.
Yes, very good morning to all, and I wish that every one of you is doing very well and safe. And I hope that I'm audible to all.
Yes, sir.
All right. So, sir, can you please enable screen sharing for my both of account through which I have logged in?
Yes, sir. Yes, sir.
Yeah.
Shortly we will
Thank
do.
you. Yeah. So, all right. Today's topic, where we are going to explore about the EV powertrain, right?
Yes, sir.
Am I right? Yeah. So there, the first thing that we need to understand is about the electric vehicle ecosystem, right? About electric vehicle ecosystem, and for understanding electric vehicle ecosystem, exploration is needed. Exploration is needed. So we'll go one by one where we can contribute and why participation of every individual who is connected to transportation system, I can say, like right from the engineers, doctors, student, faculties, researchers, business developer, business owner, everyone who is connected to transportation system needs awareness about electric vehicle, needs understanding about electric vehicle. If they do so, then it will be very clear and crystal in terms of their contribution and how they can move further in this today's time, right? So this side, Ashar Ahmed, so I'm entrepreneur and innovator working on multiple technologies in mobility, renewable energy, and automation industry, right? So yeah, so presently, I'm contributing as a skill development director for Skillshark EduTech. That is our EduTech platform for fostering skills, innovation, employability, and entrepreneurship. Right. So now, when we look at prospective, right, students or in a career perspective, right, there are different opportunities. For example, employment opportunity, entrepreneurship opportunity, research opportunity, right? And if you see as a faculty, your contribution or your inclination will be how most of the students will be getting employment, or they might get into entrepreneurship, or they might start their own research career or a masters or something like that, right? So all these opportunities, if you are talking about employment, if you are talking about research, if you are talking about entrepreneurship, these things needs skills, right? And if you see the report that says that about 90% of the employment opportunities, they require vocational skills, right? And we have to understand that India being a young country, India has 600 million young people, and they are set to change our world, specifically in the domain of automotive industry. The expected shortfall in the automotive industry in 2022 is around 35 million. So you can imagine that there are going to be huge number of opportunities in this automotive sector, right? So students, faculties, researchers, everyone has to contribute their role in this ecosystem development, right? So India's automotive future is completely electric. Let's try to understand in this perspective. When we say about electric vehicles, try to understand that electric vehicles are connected to our transportation system, right? We use transportation system for our transportation, right? For moving from one place to another place, for moving from for example, moving from Pune to Mumbai, I need transportation. There are different modes of transportation. Roadways is there, railways is there, waterways is there, right? And what I say, airways is there. So there are different modes of transportation. So what happens is, whenever any transportation system is there, whenever any particular mode of transportation system is there, that system needs entire ecosystem. Then only that particular transportation system will be able to sustain. What do I mean by ecosystem? I mean infrastructure, I mean policies, I mean vehicles, and operation. Infrastructure, policies, vehicles, and operation. These four are the key element for creating the ecosystem, right? So EV industry will create crores of job opportunities directly, indirectly. And there will be huge traction for faculties to contribute the research, that they are doing, the exploration that they are doing. And so through this, actually, I wanted to make your mind towards the fact that there are so many fields, there are so many areas that are going to emerge specifically in this EV field, and that we have to select our domain where we are better going to contribute, right? Right from the EV research and development to EV design and development, EV manufacturing, EV maintenance, EV infrastructure, EV recycling. So these are the promising areas where anyone can contribute. So it's now turn for us to decide where we actually want to contribute, right? So this was just a summary of the EV industry, and why EV ecosystem is needed, right? So we'll start our today's discussion of electric vehicle powertrain. So when we say about moving from one point to another point, right, definitely we need energy, right? For doing any work, for moving from one point to another point, we need energy. So how energy is supplied in this electric vehicle? Any participant would like to comment here, or would like to say something here? How energy is provided, or when we move from one point to another point, right? What is the source of energy in our transportation system or in our vehicles? Yes, ice engine, right? So ice engine will produce the power, right? But in that ice engine also, what we are filling or what we are giving? We are giving the petrol or diesel,
It is fear.
right? Yeah, it is fuel, right? So likewise, we have to understand, based on fuel or based on the input, right? How the powertrain architecture will vary. So basically, when we go about electric vehicles, when we talk about electric vehicles, right, electric vehicles can be categorized majorly into three types, right? One is BEV, other is HEV, and third is PHEV. Battery electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle, right? So, there is a huge difference in terms of architecture and functionality of these different powertrains in these different types of electric vehicles. And when we talk about hybrid electric vehicle, further hybrid electric vehicle is divided into series hybrid, parallel hybrid, and combined hybrid, right? So yeah, so we'll look into these different architectures, and then we'll specifically go for a battery electric vehicle, right? How powertrain works in battery electric vehicle, and then we are going to see the selection parameters for our powertrain in battery electric vehicle, right? So automotive industry in India, if you say about automotive industry in India at the present level of 2020 or 2021, before COVID, the automotive industry was performing really well, right? I hope you are aware about the automotive industry crisis that happened in the year 2008 to 10. Are you aware about that? Anyone who is aware about that? So there was an automotive crisis that happened in year 2008 to 10, and that led to multiple kind of job losses and what I say recession and several complications in the entire ecosystem of automotive industry, right? But before COVID, around year 2020, right, you can say in the start of the year 2020, the automotive industry was really performing very well. It was making a significant number of profits, and the global contribution of Indian automotive industry was at its peak. So before COVID, things were going very well, pretty much well, in terms of the American market, the European market, and Asia Pacific market, right? So automotive industry based on the geography can be divided into multiple regions like American market, European market, Asia Pacific, and all. So every I can say the domain or every market was doing pretty much well in terms of adoption, in terms of the diverging market segments, and all the different criteria or the parameters. But with COVID, there are impacts on the entire ecosystem, not only the automotive industry, but also on multiple other businesses, multiple other propositions, multiple other dimensions, right? But still, you will be glad to see that despite of COVID-19, there was so many good signs for e-mobility industry. There was growth in adoption of electric cars amid this pandemic financial year also, right? So in coming slides, we are going to see those things, and few of the thing we are going to actually explore in the coming day also. So I'm very glad to share that I will be presenting one more topic that is with related to EV ecosystem in India. EV ecosystem in India, where we are actually going to explore each and everything about the present, ecosystem development and ecosystem progress in India, right? But our today's topic or today's discussion will be majorly with related to the powertrain part, right? So now with this pandemic, with this COVID-19, there are challenges for the automotive industry to recover from the COVID impact and to come up with some cost effective models for the diverging market segment, meeting the digital demands of the industry and shifting the criteria of the kind of propositions and the products that they are offering according to the industry landscape. So these are the key challenges that automotive industry has to kind of undergo. But now, if you see what is the present status of automotive industry in India and how we are going to achieve that, right? We are actually going to see that part. So presently, are you aware that what is the position of Indian automotive industry globally? Any guess? Any guess what is the position of Indian automotive industry globally? Yes. What is the position of Indian automotive industry globally? Let me check the chat box. No one has responded to that. Okay, fine. Indian automotive industry is the fourth largest in the world. Indian automotive industry is the fourth largest in the world, having annual turnover of around $100 billion. Around $100 billion. It is employing around 32 million people, and there are different products of our Indian automotive market or automotive industry that are very significant. For example, the two-wheeler industry in India is the largest in the world. Then apart from that, we are a significant manufacturer of tractors and commercial vehicles as well, right? And our automotive industry really contributes to the development, through GDP and multiple other revenue streams, right? So why we need electric vehicles now, right? There are few of the challenges that we need to understand. There are few challenges that we need to understand. The first need for electric vehicle is that we want a sustainable future. We want sustainable future, right? So here, instead of telling needs of electric vehicle, what we can say is challenges for automotive industry, right? Challenges of traditional automotive industry or challenges for conventional vehicles, you can say. So challenges for conventional vehicle is nothing but the need for electric vehicles. So what are the challenges for the conventional petrol diesel vehicles based transportation system is, right? We actually wants to go for sustainable future, sustainable development, right? We want to reduce the pollution, since the pollution is increasing and it is impacting us in a very different way, right? From the climate change to global warming to greenhouse gases effect and multiple other things. Then the climate change has become a global issue, right? And every country wants an independent approach, right? And if you see the operational economics now, because of the increasing petrol and diesel prices, right, the operational economics or the operational cost of a particular vehicle, a petrol or diesel vehicle, is increasing day by day, right? So these are the challenges for conventional vehicles, you can say. And this is nothing but the need for electric vehicle. That is why we are needing electric vehicle as a solution for the challenges of the existing petrol or diesel vehicle, right? So can you someone justify me how electric vehicles will be able to what electric vehicles will be able to help us in order to provide the best operational economics? Yes, can someone tell me how electric vehicles will help us in the best operational economics? Let me do one thing. We'll take a blank.
Hello, sir.
Yes,
Hello,
please.
sir.
Yes,
Do
please.
you mean we are going to save the petrol and all these things because we are paying lot of money for these things to other countries, na? So if you use the
No,
electrical
no.
vehicles, it will helpful. Whatever.
Operational economics, I mean, through operational economics, I mean, for example, a particular person is running a petrol vehicle. Okay, here we are not talking about the price of the car. Okay, just think in the operational perspective. Let's suppose if you are having a petrol car and if you are having an electric car. Now, how much daily you are able to spend for running 100 kilometer in that petrol car and 100 kilometer in that electric car, right? So that nothing but comes under the operational economics, right? So let me
So,
take one example so that
EV vehicles are bi-directional. We can supply we can give electricity back to the grid. So that's why we can say that it is economical.
Yeah, let me take one example. What's your name, ma'am? One second.
So Pragya.
I can. Okay, so here we have
Sorry to interrupt
Pragya
you.
ma'am with us. Okay, let's suppose we have here, you have here 5,000 rupees. Okay, you have 5,000 rupees, Indian rupees, and you have three vehicles. One is petrol car, another is diesel car, and these cars are normal hatchback sedan type of car, and another is electric car, right? Electric car. And yeah, so now we'll do a quick calculation to understand the operational economics. Now let's suppose what is the mileage, what will be the mileage of a normal petrol car? Around 16 kilometer per liter. What will be your voice was not clear.
18 kilometer.
Sir, it's 15
Okay,
to
so
16.
16 to 21
okay,
kilometer.
let's consider we'll take inputs from ma'am 16 kilometer per liter, let's suppose. And diesel car, what will be the mileage, ma'am?
Sir, maybe 20 something we can say.
Yeah, 20 exactly. And electric car, so there are different electric cars, right? Can someone name few of the electric cars that they know?
Mahindra's one,
So Tata
Mahindra and
Altroz,
Tata. Then
No, exact name and model has to be
Tata
specified.
Nexon.
Tata Nexon EV,
Tata
exactly.
Nexon.
Tata Nexon EV, okay. Then
Tata Nexon.
Hyundai Kona Electric.
Honda Icona Electric. Yeah. So one more important part I would like to communicate here, right? One more important point I would like to communicate here, right? Exploration is always needed in the technological development that is happening in and around us. There are so many positive things, and the technological developments happens in and around us, but unfortunately we are not much aware about those things. And if we know also, we are actually not trying to understand or absorb that thing very properly. Now a quick example of it I will give you. Every one of us, hum sabko pata hai about Ola Electric. Like Ola has launched Ola S1 Pro and Ola S1, right? Am I right?
Yes, sir.
Every one of you know about Ola?
Yes, sir.
Yes. So
Yes, sir.
can
Ola
someone
Mark
tell
II
me?
also launched.
Yes. So can you tell me what
Uh,
is the peak motor power of that Ola vehicle that has been launched? Peak motor power.
something 4 kilowatts, sir.
Peak motor power I'm asking. It is given in their website. It is given in every article that you might have read. Right?
9 kilowatt.
It is given 8.5 kilowatt, 8,500 watt, or 8.5 kilowatt is the clearly specified peak power of the Ola, motor, EV motor, right? And for both the models, right, you can definitely explore. So my point of asking the question with respect to the Ola was making us understand that there are so many things for exploration and proper absorption in a proper structured way. The thing is that neither students are going in that direction, right? Few faculties might be, understanding and might be exploring those things. I'm not talking about that, but majority of us are not realizing the importance of proper exploration about the product, about the industry, about the research and all. Another good thing I would like to ask, I would be happy to see how many of you are aware about it. How many of you are aware about the solar electric boat in India? Solar electric boat in India. Anyone is aware about the solar electric boat in India? I'm not talking about the project part. It is fully functional, running solar electric boat in India. And that is not something of a product of 2020 or 2021. Believe me, solar electric boat was launched around year 2017, if I'm not wrong. Okay. So, and for sure it is, before 2020 only. So around 2017, the solar electric boat was launched, right? It is having two 15 kilowatt motors inside it, and it is present in Kerala by a company called Navalt, who manufactured it. I'm very glad to say that I'm connected to the founder of the company as well. But my point of telling you or asking you this question was, there are so many technological developments happening in and around us. One thing we are not exploring, other if we are exploring, we are not looking in detail or in depth. Since we are connected to academia, we are connected to industry, it is our whole and sole responsibility to carry forward those things. So yeah, so coming back to our point of discussion here, I was discussing with ma'am, and thank you ma'am for your patience and your inputs. So we're discussing about the operational economics of our electric vehicle. Operational economics, understanding about operational economics of electric vehicle is very important in order to understand the architecture also. Okay, so we'll quickly move to the architecture part with this quick calculation here. So here petrol price 16 kilometer, sorry, petrol vehicle mileage and diesel vehicle mileage we have written. So electric also, mileage or this electric consumption will be in terms of kilometer with particular kilowatt hour of battery consumption. So have you heard about Nissan Leaf? Have you heard about Nissan Leaf? Nissan Leaf is an electric vehicle. Nissan Leaf is an electric vehicle that consumes 24 kilowatt hour of battery for giving range of 121 kilometer. I hope my screen is visible to all and I'm audible to all. At any point, if you face any difficulty in communication, do let us know. We will be happy to rectify. Yes. So here we were discussing about Nissan Leaf. So Nissan Leaf, it gives a range of 121 kilometer with 24 kilowatt hour of battery pack. All right. Is it clear to all? Ma'am, are you there?
Yes, sir.
Yes. So now this is with respect to the mileage, I can say. Now let's understand the price of petrol. Price of petrol is what? Per liter price of the petrol?
107 in Mumbai.
Okay, let's consider Mumbai because APSIT is in Mumbai. We'll consider Mumbai. Diesel price 100. Then 1 unit of electricity. I hope all of us are aware that 1 kilowatt hour is nothing but 1 unit of electricity, right? And 1 unit of electricity price in Mumbai is what? I would like to hear from you. 7 rupees. Gaurav ji has responded. Gaurav Gadget, or okay. Gaurav ji has responded. 1 second. It is 7 rupees, right? So now let's suppose ma'am is having 5,000 rupees. So how many liters of petrol she will be able to buy from this 5,000 rupees if she wants to spend a whole 5,000 in buying petrol? So 5,000 divided by 107 will be around how many liters? Anil Kumar ji has responded 46. So let's consider the round figure 46 liter. And then diesel, how many liters ma'am will be able to buy from the 5,000 is 5,000 divided by 100 rupees will be 50. Yes, 50 liter. And then we have electricity units. So how many units of electricity she will be able to afford with this 5,000 is 5,000 divided by, it will be around 714 units, 714 kilowatt hour, or you can say 714 units, right? All both the things are same only, right? Now let's try to understand if she is traveling by petrol car. So with this 5,000 rupees of investment for the operation of that petrol car, for getting 46 liter of petrol, right, and the mileage is 16 kilometer per liter, so maximum she can operate the vehicle for a range of 16 into 46 will be a range of how much kilometer? How much kilometer, or how many kilometer? Sorry. Exactly. Here, thank you, Anil Kumarji. Anil Kumarji has already responded that for a petrol we will be getting 736 kilometer. For diesel we will be getting how many kilometer is 1,000, and for electric he has responded that we'll be getting 3600. One second, we'll check for, yeah, this is clear. Everyone is clear how 736 is there, and here 1,000 kilometer, and here 24 units 121 kilometer, then 714, sorry, 24 kilowatt hour is giving 121 kilometer, then 714 kilowatt hour, how many kilometer will be able to get? We have to just do a cross multiplication, we'll be able to get a particular value. So what answer others are getting? What answer others are getting? All right. So are you able to get my point that I was trying to communicate? So here electric vehicles are very efficient in terms of operational economics. You see here, by just spending 5,000 rupees, and again note that here we are not taking the maintenance cost into consideration. Maintenance cost will be for electric vehicle through multiple facts, and through multiple things. It is clear that electric vehicles will be having less maintenance. Why means, if you consider any petrol or diesel car, you can take a note of it. If you are considering any petrol or diesel car, how many moving components will be there in that petrol or diesel car? Anyone from mechanical domain? I would love to see your inputs. How many moving components will be there in a petrol or diesel car?
Maybe around 5,000.
Around 2,000 moving components will be there. Okay, around 2,000 moving components will be there in a petrol or diesel car. When we go for an electric car, there will be only about 20 moving components. So you see, when the moving components are drastically reducing, so definitely the maintenance will be lesser. But here we are not considering maintenance. Then also you can see here, if you see only the operational cost, using 5,000 you can travel 736 kilometer, using diesel 1,000 kilometer, and using electric, it is going far much beyond, like around 3,600, right? So 35,999 or some 3599 was there, but you can consider approximate 3,600 kilometer. So this is what actually I wanted to mean. What is the operational economics, right? What is the operational economics? For best operational economics, we are going for the electric vehicle, right? So yeah, so now the next thing that we are going to see is about the electric vehicle architecture. Let me share my screen again back. So yeah, so when we talk about electric vehicle, first when we start beginning this yeah, I would like to understand your thing. When is the first electric vehicle was made? Any guess? Exactly. So around 1830 was the time, right? Some data, some statistics say that it's 1830. Some statistics say that it is 1835 by an American scientist. Like that, there are different things. But for our understanding and knowledge, we should be clear that it is not around 1950 or 2000 or something. It is far much beyond, that year or number. So around 1830 is the first time when the first electric carriage was made, and several developments happened after that. So yeah, so Dr. Tosif has commented in the chat box saying that the maintenance cost. So near to the end of the session, we'll take all the queries and all the questions so that the flow will be consistent, right? So yeah, I would love to hear your inputs and questions or whatever brainstorming we can have, right? So here on my screen, you are able to see a gasoline vehicle, right? So we'll first see about the gasoline vehicle, then we'll go for a hybrid vehicle, then we'll see series hybrid, parallel hybrid, then we'll see the plug-in hybrid vehicle, and then the electric vehicle. And now the coming thing that is coming is the fuel cell vehicle, that also we are going to see in terms of the architecture of powertrain. And once we see all these things, we'll directly go for the the power selection part, right? So here gasoline vehicle, right? Gasoline vehicle, what happens in our gasoline vehicle is we have a fuel filler, we are filling the fuel through it. A fuel filler is there, we are filling a fuel through it. So this fuel, it might be a petrol, it might be a diesel, so this fuel is getting stored into the fuel tank. We have a fuel tank, and in that this petrol or diesel is getting stored. We have a fuel pump through which we are pumping this petrol and diesel, right, through the fuel lines to the engine. So engine here is the internal combustion engine, spark ignited engine that you are able to see. So this engine will be producing power and torque. So this engine, how it operates is it will be having a fuel injection system, it will be having an electronic control module through which it will function and produce the power and torque. Whatever power and torque produced by the engine will be transmitted via the transmission system to the drive shaft, and the drive shaft will be moving, so the wheels will be moving, and that's how that's how the gasoline vehicle or the car will be moving. Apart from this, we have an auxiliary battery here for the purpose of what? For the purpose of the auxiliary systems like brake lights, horns, power windows, and other things. So this is a pretty much clarity about the gasoline vehicle. Am I right? Now we see that there are so many challenges with respect to pollution, with respect to degradation of fossil fuels, with respect to the increased price of the petrol and diesel, and so many other challenges. That is why people and the government and the authorities are suggesting that there should be alternative to this gasoline vehicle, there should be alternative to the gasoline vehicle, in the sense petrol and diesel. And a few years back, the CNG vehicles and the other alternative schemes, now those things are also not that much effective or significant. That is why we are going for hybrid electric vehicle or electric vehicle. So now in the same architecture or in the same powertrain of the gasoline vehicle, you see, kindly capture this thing in your eyes, in your mind, right? This gasoline vehicle, if you add a motor and a battery and a controller, motor battery controller, this vehicle, a gasoline vehicle, if you are adding motor battery controller, it will become a hybrid electric vehicle. It will become hybrid electric vehicle, or you can say hybrid vehicle, right? Hybrid vehicle is nothing but hybrid electric vehicle, right? So here what happens is there will be a fuel filler through which we are filling the fuel, and this fuel will get stored into the fuel tank, and from the fuel tank it will be pumped to the through the fuel lines to the engine, and engine will produce power and torque, and this power or torque will be transmitted via the transmission system, and the exhaust gases will be relieved through the exhaust system. Apart from this, there is a battery. Battery is what? Battery is nothing but the energy storage device. It stores the energy, right? So this battery is there, it is connected to the controller that is going to control the motor. What control of the motor? It is going to control the direction, it is going to control the power, torque, RPM, everything. And yeah, so this controller is usually made up of power electronic devices like IGBTs, thyristor and all. That is why this motor controller is also known as power electronic controller. So what happens here is we have a battery pack, we have a controller, we have a motor. So this battery will be supplying power to the motor, and this motor will be producing its own power and torque. Now power and torque of the motor and power and the torque of the engine, so these two things, can be synchronized in multiple ways, series, parallel, combined. We'll see that thing. But yeah, so our point of concern here is, apart from the engine power, the motor is actually assisting the engine in terms of the power to run the car. That is how it's a hybrid system. That is how it's a hybrid system. So apart from this motor, controller, battery, there is something called DC-DC converter to step down the voltage of the battery to the system, to the auxiliary system voltage like 12 volt. Then we have a thermal system for cooling, because there is a battery, there is an engine, there is a motor, there is a controller, so many things are there. So it definitely needs a thermal management or thermal system for cooling. Then we have yeah, so here I hope you are pretty much clear with this battery pack. So this battery pack is also known as traction battery pack, as it is powering the traction motor. Then we have electric generator. Why we have electric generator here is, you see here, in order to recharge this traction battery pack, there is no external charge plug, there is no external charger. So a partial power from the engine, through the generator, will be given for the battery for its recharging purpose, right? So this is how this hybrid electric vehicle will be. I hope everyone is very clear with this gasoline vehicle and hybrid electric vehicle. Now, hybrid electric vehicle, you see there is a motor, there is engine, both things are there, right? So when two things are there, how they are combining, each other, like how is the synchronization, right? So that thing depends on that. There are different powertrain architectures in hybrid electric vehicles, saying series hybrid, parallel hybrid, and each one of it is having its own advantages, disadvantages and all, right? So here, series hybrid, right, left part you are able to see is the series hybrid, right part that you are able to see on my screen is the parallel hybrid. You see here, what happens here in series hybrid is there is a battery pack, and there is a controller or inverter, you can say. So if the motor is AC, then definitely the controller will act as a controller plus inverter, right? So there is a battery pack, there is an inverter, there is a motor. Motor is connected to the transmission, or the drive shaft, you can say. So motor is actually producing power and torque, and that power and torque is running the transmission system, and that's how the drive wheels are running. This is with respect to the series hybrid vehicle. And now, where is the engine? How engine is contributing? So engine is there, right? Engine is connected to the generator. Why engine? The output of engine will be a mechanical, and generator converts mechanical into electrical. So you see the engine, generator, then the inverter, motor. So like this, the power flow will happen here. And yeah, so I hope you can understand. This is with respect to the series hybrid vehicle. Now, parallel hybrid vehicle, it's a bit different. You can see here, right? There is a battery, there is an inverter, there is a motor. So motor is producing its own power and torque. Now engine is there, engine is producing its own power and torque, and these things are coupled simultaneously in order to run the transmission, or in order to run the drive wheels, right? So, and there will be one more system, that is a combined series hybrid, parallel hybrid, and then the combined hybrid vehicle system, where it will be a kind of a combination of both. It will be a combination of both, right? Where engine and motor can be contributing at the different levels in different point of time, right? So the vehicle can be either running on the entire the engine in one part, or it can couple the power, right? Or there's a feasibility of all the three mechanisms, you can say here, right? Then the plug-in hybrid vehicle. For understanding the plug-in hybrid vehicle, we'll go through the previous slide again. We had previously a gasoline vehicle where there is only engine at all. Okay, then there is a hybrid vehicle where there is an engine with along with the motor, controller and battery. But here in hybrid vehicle, are you able to see any plug-in or external charge? Any external charging thing you are able to see here? Any external charger, any external charger for the battery you are able to see? My question is that, Goroji, Gaurav Gadgeji. No. Right. So in this architecture of hybrid electric vehicle, in this architecture of hybrid electric vehicle, if you simply add the external charge for charging this traction battery pack, that becomes the plug-in hybrid vehicle. Can you have a look at it and understand? So here we have a fuel filler through which we are filling the fuel. It is getting stored into the fuel tank. From the fuel tank, it will go to the engine. Engine will produce power and torque. There is a battery, there is a motor, there is a controller. So motor will produce its own power and torque. Then you see there is a charge port for charging the battery that will go like will supply the charge or the energy to the charge port, and from that the energy or electricity will go to the onboard charger, from onboard charger to the battery, from the battery to the controller to the motor is producing power and torque, right? Auxiliary batteries for auxiliary systems, we have already knowing that thing. Onboard charger is actually the charger for the battery. So onboard charger will be 3.3 kilowatt or whatever the power it will be. Now is the key part, our electric vehicle. Our electric vehicle is very simple and sweet mechanism. There's a battery, motor, controller, charger. That's it. Battery, motor, controller, charger. That's it. Other are the auxiliary system like DC-DC converter, thermal system, auxiliary battery, and all those things. Transmission, brakes, suspension, wheels, body, everything is similar to the what we have in present vehicles also, in conventional petrol diesel vehicles also. So chassis, then suspension, brake, and what else is there? Steering, then auxiliary battery, transmission, differential. These things will be same. The additional things that are the key things are the battery, motor, controller, charger. These are the key things in our electric vehicle. So we charge the battery. How we charge the battery? We supply the electricity. So electricity will be entered to the charge port. From the charge port, will go to the onboard charger. From onboard charger to the battery. Then the battery will store the energy in the form of chemical energy. And then during the discharging, that electricity or the supply or the voltage or the current will go from that battery to the controller to the motor will produce power and torque, and that's how the electric car will move, electric vehicle will move. This is with respect to electric vehicle. I hope this is clear to all. If yes means we'll go for this fuel cell vehicle.
Yes, sir.
Yes. Now in terms of fuel cell vehicle, you can see here, right? Fuel cell vehicle, you can note down what I'm trying to communicate. Fuel cell vehicle is a special type of series hybrid vehicle. If you see the architecture of series hybrid vehicle, you will be able to correlate it that fuel cell vehicle is a special type of series hybrid vehicle, series hybrid electric vehicle. Let's see what happens here is, so there is a fuel filler. What is the fuel here? Fuel is the hydrogen. So we are going to fill the hydrogen. So hydrogen will go, and where it will get stored? It will get stored into the fuel tank. So fuel tank will store the hydrogen at a particular pressure and temperature, and this hydrogen will be stored into the fuel tank, and from the fuel lines, or you can say from the supply or the mechanism, it will this hydrogen will enter the fuel cell stack. I hope you all are aware about the fuel cell stack. So in fuel cell stack, what happens is, in fuel cell stack, our the chemical reaction will take place. The entire reaction will take place here, and this reaction will lead to the generation of energy or power. And this energy and power, okay, whatever output is getting from the fuel cell stack, can be stored here into the battery pack, right? And the same energy and power will be utilized for driving the motor. And as you see, motor always needs the controller. So here also, from the fuel cell stack to the battery to the controller to the motor to the drive shaft, right? That's how the power and torque will be transmitting. The rest all things are almost similar. right? This is a fuel cell vehicle, right? Now I would like to understand many things from your end, right? uh, Organizers can let me know, do we need to give some break or something in between? Is there any formality, something like that? Do let me know, or else we can keep continuing,
No,
right?
sir.
So here
You can continue.
I can continue, right? Thanks a lot, thanks a lot. Yeah. So now let's try to understand the the key part, that is with respect to motor and all, right? Before that, I would like to take you through the different hybridization levels that happens in the EV powertrain part. Different hybridization levels that happens in our EV powertrain part. One second, let me get back to the screen again.
Sir, hydrogen is very hazardous now, but
Yes, so you see, there are challenges. There are challenges with respect to these different vehicles, right? When we talk about hydrogen, not only the cost parameter we have to consider here, but also the hazardous part of it we have to consider, right? So presently, hydrogen fuel cell vehicles, specifically in India, why they are not too much trending or too much you can see a battery electric vehicle on road, but presently you'll not be able to see the fuel cell vehicle on road because of challenges of the safety as well as the cost. Okay, I will tell you, I'm glad to say that I got a chance to explore the EV market not only in India but also in other countries.
sir, you are
Vehicle,
muted.
pardon?
Uh, Actually, your voice, I didn't got your voice because of muting or something. You were mute,
Okay, okay,
keep
no
it.
problem. Acha, acha. I was telling that I got a chance to explore the EV market in multiple other countries as well. So in Shanghai, I've seen multiple electric vehicles, and many of the energy storage system. You see, now electric vehicle concept is pretty much clear to all. Only the thing is with respect to energy storage, how they are storing energy. Is it through ultra capacitor, or through a battery, or through a fuel cell, or what is the energy storage mechanism? That is varying, and many pilots and many prototypes are being done. So with respect to hydrogen, it is, as you said, the safety parameter is one part and the cost parameter is one part. So there is a company based out of, I think, Poland or Finland. Okay, so they had an interaction with me saying that they want to have electric bicycle in India. Okay, they want to have a fuel cell based electric bicycle in India. Okay, at a time, ma'am, when we calculated the landing cost and the cost that we can offer for that fuel cell based electric bicycle was around 1.5 lakh Indian rupees.
Pray. Nobody will purchase. For common
So
person, it's very difficult.
exactly. And what I was trying to say was, with respect to this thing only, we have to actually have, not only product is important, the entire ecosystem is needed. Believe me, if today we have electric cars on road and if we have charging station, then also electric vehicle technology is not sustainable. Why means we need ecosystem, and that ecosystem means right from what I say, energy generation, right? Electricity generation to energy transmission, energy distribution, grid management, charging infrastructure, home charging station, commercial charging station, then battery recycling, powertrain production, then what happens, battery manufacturing, skilled workforce, insurance companies for electric vehicles, finance companies for electric vehicles, and what else? Yeah, all marketplace for electric vehicle, all these things together, then only electric vehicle technology will be a sustainable technology. And in all those things, in Indian perspective, the TCO is very important. The total cost of ownership is very, very important. Believe me, in today's time, there are so many resources available, there are so many developments happening, and I suggest all of us, all the faculties, students, researchers, those who are present today, right? It's our term to actually explore about the things. Usually I ask this question to the participants, right? but I would like to float this question again and see how we are right. We are much concerned with these developments and other things. So my question is: every one of us is aware about what you say, distance. If I divide distance in time, distance by time, what quantity I will be getting?
Speed.
Right, speed. And if I divide speed by time, what quantity I will be getting?
Distance.
No.
You want velocity, you want meter per seconds, na? So meter per second velocity will be there.
So if we
Accelerator will
exactly.
be
So if
meter
we have,
square per seconds and velocity will be
yes,
meter per second.
yes, ma'am. So what happens is distance we have. If we divide distance by time, we'll be getting speed. Speed, if I divide by time, we'll be getting acceleration. Now, acceleration, if I divide by time, what will be the quantity?
Momentum.
Not exactly. Exactly, Mr. RH Singh. Mr. RH Singh has commented in the chat box saying jerk. So there is a vector quantity called jerk that exists if we divide acceleration by time, right? And yeah, again, if we divide jerk by time, there will be another quantity, right? Jounce that will be there. So like that, the whole essence or the whole objective of the question was saying that it's the time for us to explore more about beyond the particular limit or constraint, and exploring each and everything about the technology that we are concerned with, specifically the engineering and technology domain. There are so many developments happening, and we should definitely explore more and more about it. So coming back to our discussion, so we here you see there are different systems and subsystems will be there in our electric vehicle, right? So chassis, wheels, and all those things will be common, but the battery, motor, controller, charger, wiring harness, these will be the key part. Now uh, what happens is, you see, conventional vehicle to electric vehicle, this transition is taking through different hybridization levels. You see, why I am spending much time on these things is, these things are important in order to understand the powertrain part, right? What is BEV, what is HEV, what is PHEV, what are the different hybridization level, what is micro hybrid, what is medium hybrid. These things, if you understand, then the powertrain essence or the powertrain flavor you will understand, right? So here you see there is a conventional vehicle at the left and there is an electric vehicle at the right. Now transition from conventional vehicle to electric vehicle will happen through different steps. So micro hybrid electric, medium hybrid electric, full hybrid electric, plug-in hybrid electric, and electric. And when the transition is happening, the contribution of engine will go slowly down or slowly less, and the contribution of motor will increase, and it will come to the maximum of it to the electric vehicle. Examples of micro, medium, full, and plug-in are these things. And I guess there is a assessment also after each session or something like that. So try to explore more and understand more so that you will be satisfied, right? So here I hope you are able to understand what I'm trying to communicate. So what happens is, in no hybrid there will be only engine which is actually starting and stopping. We are running the car. In mild hybrid, along with the engine there is a regenerative braking. In medium hybrid there is a engine, regenerative braking, as well as the motor assist. Motor assist means only the motor is assisting the engine for producing the power. The medium hybrid vehicle cannot be run entirely on EV. Then comes a strong hybrid where there is a engine, there is a regenerative braking, there is a motor assist, and the EV drive where the EV, like the vehicle can be run completely on EV, on a EV drive mode. Then the plug-in hybrid comes where engine, regenerative braking, motor assist, EV drive, and the external plug-in for the charging is there. Then comes the electric vehicle, right? I hope now you all are pretty much clear with respect to the architectures of these electric vehicles. Now our next discussion or the next point will be with respect to the powertrain, where we are going to explore about the these things, right? That we are discussing. Second, let me share my screen back. So motor battery controller are very important. So what happens is, the power flow from the battery to the motor will go through the controller, and this controller will control the amount of energy, will control the voltage, current, RPM, everything, right? So based on the throttle input, we'll be getting the output. So here, motors that we are able to have for electric vehicles are known as traction motors, and these motors that we are selecting must be energy efficient, must be durable, must be compact. Now let's understand the few parameters and few of the test examples, and then we'll go for the actual selection criteria, right? So here what you are able to see here is, on my screen, different motors. So these different motors will be having different application in EV industry, right? So a 15 kilowatt motor can be used for an electric car, or it can be used for application of, you can say, right, a particular car or a particular hatchback sedan kind of vehicle. If it is there, means this 15 kilowatt traction motor can suit there. Then 8 kilowatt traction motor. So this 8 kilowatt traction motor is suitable for small electric vehicle where speed you need around 45 kilometer per hour. Then 4 kilowatt traction motor is there, right? 4 kilowatt traction motor is there. It is suitable for golf cars, ATV and all. Then we have 1.5 kilowatt traction motor. This motor will be suitable for scooters and go-karts, right? Now, when we see a particular motor, then we have to understand the powertrain criterias and the parameters as well. So each motor, each vehicle will be associated with the different parameters. So here now we'll explore as per the vehicle part. So you see there is a car, there is a kind of van or LCV, then there is a shuttle, and there is a scooter. Now you see, now if you want to make, or if you want to make an electric car, you want to make an electric car, it's a hatchback or sedan or a compact kind of electric car. For that, you need a nominal power of 15 kilowatt. The peak power, can be of 27 kilowatt or more than that, right? So these are the case studies we are seeing, just to understand that, how the real time product is in the market, right? So here we are going to see a particular electric car. So this electric car, it utilizes 15 kilowatt nominal power motor and 27 kilowatt peak power. So apart from motor power, there will be another parameter that we need to understand is the torque. So torque here will be around 100 newton meter, speed is around 8000 rpm, and weight of the motor is around 43 kg, right? So this motor can be implemented in electric automobile, electric car, like that. Then another motor is there which is having nominal power of 8 kilowatt and a peak power of 15 kilowatt, rpm of around 6000, and a torque of around 70 newton meter. Then we have, for shuttle, 4 kilowatt nominal power, 7 kilowatt peak power motor can be used. It will be having a torque of around 45 newton meter and rpm of around 4500. Then the electric scooter, which can be implemented with 1.5 kilowatt or 2.5 kilowatt motor, right? 1.5 kilowatt is the nominal power, 2.5 kilowatt is a peak power. The torque is around 18 newton meter, speed is around 4500. The reason why I'm showing you, or I'm trying to communicate this thing, is to you to understand that how powertrain parameters will be there in real electric car. So in this electric car, you see a 15 kilowatt and a 27 kilowatt motor power, nominal peak is there, torque is around 100 newton meter and all. Now if you want to develop your own electric car, or if you are planning to make an own electric car project or something, this market exploration, this product exploration will help you out in, heading in the right direction, right? So here, if a similar kind of electric car you want to make, then the approximate power consideration should be around 15 kilowatt. If you are going to make an utility car, or for loading unloading purpose, something like that, then 8 kilowatt nominal power you can go with, right? If you are making an electric shuttle, then around 4 kilowatt of nominal power you can choose. If you're going for an electric scooter, around 1.5 kilowatt, 1 kilowatt nominal power you can choose. So these things will actually help us in heading in a right direction towards the power selection, powertrain selection part, right? Now, let me come back to the important part, that is with respect to the selection part. One second, let me, right? So here in our powertrain, what is happening in our powertrain? What is happening is there will be motor. This motor will be producing power and torque. Is it clear to all? So selection of the motor will be very important because motor will be delivering the power and torque, right? So this motor, I think someone has commented here, Mr. Devan PK has commented that throw more light on power and torque. Yes, we are now, the left out session is going to be on this calculation and the power and torque part only, right? So here what happens is our motor is going to produce the power and torque, so we have to be very specific in terms of our motor selection, because motor selection, based on the motor you will select the controller and battery, right? So let me give you the clarity about it. So what happens is we'll select a particular motor. For example, I want 1 kilowatt motor. If I know the power of motor, I should know the voltage of motor, right? So one second, let me show you here. Now how we'll go about it is, for example, now I should know the power of motor, right? I should first calculate what is the power of motor. Let's suppose I've done a particular calculation, I've got that my motor power is 1 kilowatt. Then the next thing I should know is my motor power is 1 kilowatt, but what is my motor voltage? Then I will do the calculation, I will find, okay, my motor voltage will be 48 volt. Then I should know my controller voltage, and controller specification. I think I missed R here. Where is my, yeah, controller specification. And yeah, so then the battery. So the battery selection, how it will happen is, battery selection will happen based on the motor voltage. So motor voltage is 48 volt, means minimum of 48 volt has to be supplied by the battery, right? Then the voltage of the battery, then the AH of the battery. So the battery AH will be depending on the capacity or the range that we are intending at, right? And this selection actually depends on a parameter called watt hour per kilometer. That is nothing but the consumption of the energy that is happening. So this is the actual way how we deal with the selection, how we deal with the selection of motor, controller, battery and all. So now our prime focus will be on the power, torque, RPM and these parameters today. Since till what time we have the session, sir? Anyone from organizing team? How much more time is left for me?
So around 40 minutes.
40
40 to
minutes.
50 minutes here.
Makes sense. Yeah. Makes sense. Thanks a lot. Yeah. So here, this is very, very important. So motor selection. So there are steps in selecting the motor. First, you have to select the motor type, AC motor or DC motor. So can you tell me what are the different types of motors available? See, more we interact, more we'll be having clarity. More I will be happy, more you will be happy. AC, DC. Okay, so
LDC.
can someone tell me? Yeah, can you someone specify what are the different types of motors in AC?
Which is used for the electrical vehicle, induction motor,
Electric vehicle application. Yes.
slip ring induction motors.
Okay.
PMDC, no, that is synchronous motor.
Yeah, so here what happens is motors are of two types, as we know. Yeah, sorry. So motors are of two types, AC and DC. In DC, we have permanent magnet DC motor that can be used for EV application. We have brushless DC motor, right? Then we have brush DC motor also that can be used. So these are the different categories in DC motor that usually we use. Nowadays, BLDC is the key DC motor that is getting implemented in multiple electric vehicles. Coming to the AC, in AC, the induction motor and synchronous motor, these are the important motors that are getting application in EV. In synchronous three-phase AC induction, sorry, in the induction motor, three-phase AC induction motor is getting utilized in multiple electric vehicles. And in terms of synchronous permanent magnet synchronous motor is there, then switch reluctance motor is there, like that different motors are there, that are getting implemented in electric vehicle based on the application and based on multiple things. There are so many selection criteria. Today will not go in depth into that. Okay, so motors are of different types. We have to select a particular motor, whether we want AC motor, DC motor, whatever it is, right? Then we have to select the power. So once we select the power, then we can go for the voltage selection of the motor, right? Then we can see what is the cost, and then we can determine the size and performance of the motor, and accordingly we can finalize the motor, right? So for selecting the power, we should have a particular calculation approach. There are different calculation approaches available. You can select either of it, right? We will be taking one particular example, right? So that you will be getting a clarity about the power and torque and RPM and all those things, right? So here we should know that what is the mass, right? What is the gear ratio? What is the transmission efficiency? What is the coefficient of rolling resistance? Mass is nothing but the total mass of the vehicle, including the driver, including the load, or you can consider the complete mass of the vehicle, right? So that is going to be the mass. For example, if I'm having an electric bike, so the weight of that electric bike, including chassis, motor, battery, everything, then weight of myself and the weight of other person or the load that I'm going to carry in my bike, so that will be the entire mass, right? Then the gear ratio, whenever there is a motor, and if we want a variation in the RPM or the torque or the power of the between the shaft of the motor and the drive shaft, then we can use the gear system or the gear ratio or the transmission in between, right? So the gear ratio will be there. It will be of like 4:1, 6:1, 8:1, 10:1, like that. Transmission efficiency. So what happens is transmission efficiency, uh, you know, uh, whenever the power transmission is happening, so there will be some losses. So that's how we calculate the transmission efficiency, and we consider transmission efficiency up to 90 or 95%, like that. Then coefficient of rolling resistance, whenever the car is rolling on road, there will be the friction, and that resistance or that friction in case of running of car will be the rolling resistance, and we have to consider the coefficient of rolling resistance, CRR, into consideration. CRR value is standard and constant one available in internet for multiple applications. CRR will depend on whether it is a tar road, whether it is a mud road, whether it is a concrete road, whatever it is. Then vehicle frontal area. Whenever a particular vehicle is there, the frontal side of the vehicle will be getting exposed to the drag force or the aerodynamic drag. So for that purpose, for calculating the aerodynamic drag, we will be considering the vehicle frontal area. So for a car, it will be of a rectangular shape, right? So depending on the front size of the car, it will be accordingly. Then the wheel radius. So what is the yeah what is the radius of the wheel, right? Then what is the average velocity that we are considering, and what is the inclination, right? Then what is the drag coefficient? So drag coefficient will depend on multiple vehicles, like whether the drag coefficient for cycle will be different, for car will be different, for truck will be different. So it is also a constant value. So what has to be done? We should have these values in a structured way with us in order to go for the further calculation. Mass, mg, efficiency, crrg, cd, af, density, rwv, and gradient. These things should be there in proper units with us. Once we have these things, we can go for calculating rolling resistance force, then calculating the first thing we have to calculate is the rolling resistance force, then the rolling resistance power, then gradient resistance force and gradient resistance power, then aerodynamic force and aerodynamic power, and then the total power and total power with efficiency. That is how we'll be getting, that is how we will be getting, that is how we'll be getting where it went. Yeah, that is how we'll be getting the motor power. Okay, and then once we get the motor power, we can get the motor voltage and other things. Okay, so you can have a look here. This is how we have to go in a particular approach. We should have these values in a particular units. Once we have these units, we can go for further calculation. Now, any one of you have seen electric bicycle? Am I making you bore?
No, sir, it is interesting.
It's interesting, right? So do respond, right? Anyone have seen electric bicycle? Anyone have taken the drive in electric bicycle? At least any one of you have seen an electric bicycle? Yes, Dr. Asha. Dr. Asha is saying that has seen the bicycle. So what was the like model, or what was the like particular make? Who was the manufacturer? What bicycle you have seen or driven, whatever? Yes, ma'am.
Sir, it is local made, sir. Our students made, sir. I am a faculty in GH Raisoni College, Pune. So our students here with the copy, which is College of Engineering and Technology, they made that for the project
Very
purpose
nice.
of the B project purpose. So we saw that by the, but we didn't try. Even bicycle also done, project on the bicycle also done by my project. Along with the Prayas group in Pune. Prayas group, if you have heard about them, they are working on the electrical vehicles also. So
Okay.
they have prepared that, sir. It is not
Very
for
nice.
any companies or somebody. So.
Right. No, any company product anyone has seen? Dilip ji. Then we have Gaurav ji. Okay, student project made. Gaurav ji is telling. RH Singh, Mr. RH Singh has said yes. So RH Singh ji, can you throw a light on it?
Sir, actually, I have seen from distance, not the company. Actually, I'm not able to recall.
Okay.
Made of.
Okay. See, I'll repeat my suggestion for all of us. You know, there are so many good products. There are so many good websites available of these products. Only thing is that we have to go explore, understand what is their product, what is their weight, what is their motor power, and all. Through this exploration, you will become, expertise in selection, in calculation, and all those things. And at some point, what will happen is, you know, you need not do calculations also. If someone is telling I want to make electric bike, you'll tell boss, go use 1.5 kilowatt motor. What is your weight? Okay, my weight is 100 kg, 120 kg. Go use 1.5 kilowatt motor. You can use a BLDC motor or PMSM motor, whatever it is. Through exploration, you can reach to this much clarity, right? So yeah, so we'll take an example of electric bicycle. In India, electric bicycles are available. So many electric bicycles are available. I will tell you, as I said, I'm a serial entrepreneur and innovator. So we keep doing various innovations into this EV domain, into specifically not only EV, renewable energy and mechatronics. So from 2014, 2014 was the year, when we made the first, like, our own team, we made the first electric bicycle and all. And have you heard about retrofitting? Have you, any one of you, heard about retrofitting or converting existing petrol diesel vehicles into electric? Yes,
Yes, sir.
Shubha Rao ji, yes, you have heard. Have you
Yes,
seen
sir.
any of that particular car or something?
Sir, in near Pune, there is a one place in Kharadi bypass road. There one company,
Okay.
they are doing these
Okay.
things, sir. And they told me about the Tata Nano, they can convert into the electrical vehicle. But the initial speed, pickup and all the things will be changed. And they told me to it will be cost around 1 lakh rupees.
Okay. And anyone else has seen? Anyone else who has seen? Ankit ji. Yes. What you have seen, what you have read, can you explain a little bit? Can you see my screen?
Yes, sir. Yes.
Ankit ji, are you talking about this thing? All right. This is myself, Ashar. Okay, here standing along with IT Secretary, Government of Telangana. Here we made this retrofitted electric car. Okay, as a part of our previous startup. Okay, so you see, here our exploration actually helped us a lot in order to come up with a particular kind of product, right? And selection of the component and all those things. So that is how I'm stressing on the exploration part. So here we have used 15 kilowatt three-phase AC induction motor, 15 kilowatt three-phase AC induction motor, and 20 kilowatt hour of battery pack, 20 kilowatt hour of battery pack. See, we got a huge traction and good number of inquiries with respect to these different products. You see here, we even kind of taken feedback from the different stakeholders of the industry as well, right? So yeah, so my point was exploration will definitely help you out in the kind of achieving the right outputs and outcomes, right? So yeah. So with respect to retrofitting, what happens is every vehicle, that particular model or particular vehicle that you are converting into electric, has to be certified by ARAI or ICAT, and the certification has to be valid for a particular model. If you're taken what you say a particular if you're talking about Alto, if you're taken certification for Alto, you cannot use the same kit for converting Wagoner. Again, you have to take the certification, right? So retrofitted cars, scooters are permitted in India. It is permissible in India, but certification and cost of conversion, total cost of ownership, so many challenges are there. That is why presently it is not getting much of acceptance. And yes, scooters are also permitted. Two-wheelers are also permitted. Since we are into this EV ecosystem, we are connected to the companies that are offering two-wheeler conversion, four-wheeler conversion, and all those things. So yeah, coming back to
Sir,
our
their
point of
IS
discussion
standards
was,
are there, sir. Which standards, IS standards are used for this thing, sir? For electrical vehicles, sir.
Electric vehicle, there are, you see, the component wise, the what you say, the safety wise, there are different standards. Okay, there are different standard with respect to safety wise and all those things, but major regulations that goes into electric vehicle will be under the Ministry of Road Transport and Highways, Government of India, and there are authorities dealing with the each and every aspect of electric vehicle architecture, voltage, current, and safety, multiple things. And these authorities are ARAI or ICAT. ARAI is based in Pune, ICAT is based in Haryana, Manesar, right? So that is how the whole regulation is actually dealt with, right?
Is it
So
is it true, sir, that we are following most of the German standards, not Indian standards for the
no,
electrical vehicle?
Indian standards we have framed with reference to the many other European Union standards. We have framed. We have our own Bharat standards for even for Bharat DC charging, Bharat AC charging. We have our own standards and all, but we have referred to multiple international standards for global adoption and all. So yeah, so you see, as I told, still EV ecosystem has to be there, right? So many developments, so many progress will happen in coming days.
Okay, sir.
So we'll take a particular example of electric bicycle. Participants will move further near to the end of the session. We'll go for a Q&A. There I would love to hear each and everything from your end. Gauravji, your question will answer at the end. Okay. And yeah, so electric bicycle, we are taking a particular example to make sure that we are pretty much clear with this power, torque, and RPM and all. Electric bicycle, so weight of electric bicycle will be around 100 kg. How 100 kg is? The bicycle structure, the frame will be around 8 kg if it is of aluminum body. 8 kg motor and gear will be of 4 kg, controller will be of 1 kg, battery will be of 66 kg, and the driver or the rider will be of 80 kg if it is a single rider, and auxiliary 1 kg weight we are considering, means total weight of a particular electric bicycle looking like this will be around 100 kg. In Indian market, EV electric bicycle manufacturers are using 250 watt BLDC motor, 250 watt 36 volt BLDC motor, and they are using 36 volt 10 Ah 6 Ah 8 Ah battery packs, right? So these understanding, if we have priorly, will help us in selecting and going for a particular product. Okay, so once we have this understanding of what is the total mass, 100 kg is the weight, right? Then we have to understand the free body diagram where the weight is actually coming, the front wheel, rear wheel. So 75% of the weight will come in the rear wheel, so we'll go for a rear wheel drive here. So if we see the free body diagram, okay, we'll be able to understand that we have to have the tractive force so that we'll be able to overcome the particular gradient and particular thing. So here is available bicycle can be converted to e-bicycle without any permission from agencies or government. For bicycle, there are not much regulations. Okay, any vehicle more than 25 kilometer per hour speed has to be certified. After retrofitting, has to be certified from government. So there are different regulations. Okay, we'll take the question at the end. Okay, so here coming back to our discussion. So for electric bicycle, mass is 100 kg. Gear ratio, if you want any gear mechanism, 6:1, like that we can keep. Transmission efficiency is 90%. CRR, let's consider 0.016. G is 9.8. CD is 0.46. Vehicle frontal area is 0.5 meter square. Since it is a cycle, the vehicle frontal area will be very less. And density 1.225, wheel radius 0.2 meter, velocity is, let's consider 25 kilometer per hour, gradient is 1 degree 2 degree, whatever it is we can consider. So we have to have a clear picture of these inputs. Once we are having clear picture, then we can go for calculating rolling resistance force. So we'll calculate rolling resistance force by CRR into M into G, and we'll calculate the rolling power. So can someone calculate and tell me what value you are getting?
0.016, sir.
Yes. So 0.016.
16.
What is this value? Yeah, so this 15.696 will be the force, right? Rolling resistance force. So how we can convert the force into power is multiplying the force value with velocity and dividing it by 3600. Why 3600? Because you see here, velocity 25 kilometer per hour. So kilometer per hour to, we are converting it to our convenient unit, right? So that is how we are converting it into dividing it by 3600, like per hour to per second. So rolling resistance power we will be able to get. All right. Then we have gradient resistance. We can calculate gradient resistance by using formula mg sine alpha. Alpha is in degree, so sine 3 degree, like that you have to calculate. If you just put sine 3, it might take the radian value or it might take the other value. So make sure you are calculating mg sine alpha by putting mg sine 1 degree, 2 degree, whatever it is.
$17.12 for sine alpha equal to 1 degree.
Great, ma'am, great. That's absolutely right. So this will be the force value. We can convert that force value into power by multiplying with V and dividing by 3600. So we'll be getting a particular gradient resistance power value, right? Then aerodynamic drag. So aerodynamic drag, when the speed is high, for 25 kilometer per hour and all, it is chill. That's not too big problem for us. When the speed is 60, 80, 100, 120, like that, aerodynamic drag will be, for sure we have to consider it, right? So 0.5 into CD into vehicle front area into rho into velocity square. This is the formula. Since the velocity is in kilometer per hour, right? In order to convert kmps to meter per second, there will be a conversion factor. That is how we are using that in order to convert that into meter per second, so that we'll be getting all the values in a SI unit and we'll be getting the force value in Newton. Gauravji, Anilji, these people are very, very active. They give answer very quickly. I think they have done abacus or Vedic mathematics something. Yes, Anil Kumar ji, have you done Vedic mathematics, abacus something? Nice, nice, nice. So I have completed my abacus and Vedic mathematics. Those things are also very, very interesting. Yes, yes, yes. I too have certification in abacus as well as Vedic mathematics. These two things are very, very interesting. Now, if you get chance to encourage your students or your kids to enroll for it, definitely do encourage them for extracurricular productive activities. Yes, what value you are getting? What happened, ma'am? Ma'am is, I think, calculating. Yes, I'm waiting. See, time is flowing like anything. You have to be quick here. Gaurav ji, Anil ji. Exactly. So Anil Kumar G has commented. So all right. So this will be the aerodynamic drag. So now if we add the three powers, we will be able to get the total power. And if we want to consider the efficiency, okay, then we can divide the total power by efficiency to get the total power with overall efficiency. Right. So now here we are able to get this total power with overall efficiency. So this will be the power. This will be the power that is required for running our bicycle that is standing in a mid of inclination of 1 degree, and this bicycle we want to run at a speed of 25 kilometer per hour. Then this will be the power required. Okay, so this will be the power required. So what happens is this will be the power, maximum power required to run at a speed of 25 kilometer per hour. Sometime you might be running at 20 kilometer or 15 kilometer like that. So the power variation will happen according to the speed that you are actually running at. But here this will be the requirement. So what happens once you get this value after calculation, you have to see your requirement of 300 watt of power. So you need a motor that can give you a 300 watt or 310 watt of power. Okay, so in market you'll start go and search about the motor. So in market motors are available of 250 watt power that gives a peak of 300 or 350 watt. Okay, majorly these motors are Chinese manufactured motors. In India still companies are setting up the supply chain as well as the production facilities for the motors, controllers, batteries and all. Presently in India the battery assembly happens in a large way. The battery cell manufacturing is still under process, but motors and all, because they have mass production units in China, so the things comes at a very affordable price. That is why manufacturers, dealers and suppliers, they go for that kind of thing. But in coming days we wish to see that India will also have the own organized supply chain and manufacturing units for all these things. So as what I was telling, the motor that is available in market is giving 250 of nominal power and peak of around 300 350 watt. Okay, and we can go for that particular motor. So okay, so once we are, what we have to do, we have to calculate the power. Once we have calculated the power, the next thing will be the voltage of motor. So we'll see how we'll calculate voltage of motor. Before that, let me conclude the RPM and the torque part as well, because RPM and torque, if you are familiar, if you are clear, means the whole objective of today's session of power selection or powertrain selection will be clear to you all, right? So now we have got the power. We have got the power here. So now what happens is our motor speed will be there. So here this vehicle speed, what happened, let me see what happened to the screen. Yeah, is it clear? Yes. So here you see, with a velocity of 25 kilometer per hour, right? If we are able to get a particular RPM, if we are able to get a particular RPM, okay, at the motor end, that will be the speed of the motor. Now if we connect any gearbox to the motor shaft, or to any gear mechanism we are connecting to the motor shaft, then there will be two speeds or two RPM. One will be I I hope my screen is visible to all.
Yes, sir. Yes, sir.
So I don't know what happened. There is some connection issue or something. Yeah, so I was telling that when we have a motor, we have a motor shaft. So motor shaft will be delivering a particular RPM. There will be a particular RPM associated with the motor shaft. Now, if we connect any gear mechanism in between the motor shaft and the drive shaft, then there will be two RPM that will be getting. One will be the RPM at the shaft of the motor and other RPM at the drive shaft. Okay, so here motor speed or motor RPM will be calculated using the formula, this formula, and shaft speed will be calculated using the similar formula with introduction of G, gear ratio, right? That speed will be enhanced RPM or enhanced speed. Another part will be with respect to the traction torque. You see the total power that we have got using that formula, using that value, and using this formula, we can calculate the traction torque. This traction torque, okay, will be the torque at the shaft of the motor. Torque at the shaft of the motor. But if we have any gear mechanism, any transmission mechanism with the gear and all in between, then the torque at the shaft of the motor will be different from the torque at the drive shaft. Are you getting my point? That is how we have to use the G factor for calculating the gear ratio, or the G factor for calculating the load torque or the torque at the drive shaft. So using this formula, you can easily calculate what is the motor speed, what is the shaft speed, what is the traction torque, what is the load torque, or what is the end torque you are getting at the shaft. So for a clear understanding, let me show you. One second. I have a picture or slide that might give you a bit of clarity. Yeah, I have something to show. Yeah. These things I will make sure that you get all those things, all these slides and all this thing during the EV ecosystem part, because in EV ecosystem I'm going to demonstrate and show you all these things. But for your understanding as of now, can you see here? This is the motor. This is the motor. So here will be the motor shaft. Okay, and here is the final where the wheels or the wheel hubs are going to be attached here, right? Now, motor shaft or motor will be producing a particular RPM or torque. Here is the gearbox, the differential, and this axle. Now, there will be one RPM that will be at the shaft of the motor, and another RPM at which this drive shaft will be moving. Are you getting my point? What I'm trying to communicate? If yes means we can move further ahead.
Yes, sir.
Yes, Mr. RH Singh ji, that 9.5493 is not the gear ratio actually. Gear ratio is represented using G. That 9.54 whatever is there is the conversion factor. You might have seen from angular speed to what is that, linear velocity to angular velocity to pi by 180, like that you might have seen. That is nothing but the conversion factor.
Okay. Thank you, sir.
Understood. I hope you understood, right? So yeah, so the last thing that we have to see is the motor voltage, and the rest of the things will go in a clear way for you, all of you. Then with that, I will conclude my today's discussion, and then we'll go for a Q&A. Okay. Now, what happens is, let's suppose we have got the motor power, we have got the RPM, we have got the torque, everything. We got a clarity about it. Now we know motor power. What should be the motor voltage? That is another question. So motor voltage, actually calculation of motor voltage goes in a various ways, various approaches, right? Calculating the system voltage, calculating the power, calculating the power consumption, watt hour per kilometer, multiple kind of approaches are there. One of the approach, or one of the uh, approximation method, or one of the easy quick method is trial and error method. Trial and error method, what happens here is, you see, uh, what happens is 250-watt motor is there. Okay, so there can be different voltages. It can be a 12-volt 250-watt motor, it can be 24-volt 250-watt motor, it can be 36-volt 250-watt motor, it can be 48-volt 250-watt motor. Am I right? So what happens is, in different voltage levels, the current value will be varying. 12-volt 250-watt motor, current in that case will be around 20 ampere. That is very high. That is very high. 24-volt 250-watt current will be around 10 ampere. That is also very high. So we can go for 36-volt. 36-volt 250-watt, the current will be around 7 ampere. That is okay. If you go for 48-volt 250-watt, current will be 5 ampere. That is good. But we have to be effective in terms of the current, in terms of the system voltage, also the pricing. You see, if I go for 250 or 36-volt motor, okay, I will be needing only 36-volt battery. That means if I'm using 3 batteries of 12-volt, I only need space for 3 batteries of 12-volt and money for buying only 3 batteries. When I go for 48-volt, in order to reduce the current, in that case, I need 4 batteries. I need more space. I need more money to buy 4 batteries. Are you getting my point? So selection of components, selection of powertrain deals with multiple aspects. One day 1 hour is not actually sufficient for these kind of things, right? But yeah, definitely, I hope you might have got a clarity about whatever I actually intended to communicate, right? So at any time you feel anything to discuss, anything to brainstorm, any doubt or something, you can feel free to contact me. I think at the initial point itself, I have shared my LinkedIn profile and all, so you can feel free to contact. I will once again put my the profile link here, so that you can communicate easily at any point, even after the session. Also, any doubt or something,
Sir, screen
feel
is
free
not
to.
appearing, sir. Screen
Yes,
नहीं
I
दिख
have
रही
closed.
है.
Yes, ma'am. Screen बंद कर दिया हमने. Screen I have closed. Okay, and yeah, I have shared my LinkedIn profile, and yes, now we'll go for a Q&A. So I'll first take the question that was there from Mr. RS Singh. I have told that 9 point is nothing but the conversion factor. Then is available bicycle can be converted to e-bicycle without any, yeah. So available bicycle can be converted to electric. Okay, as I said, bicycle, since your existing bicycle is not having any RC book, is there any RC book for your bicycle?
Yes, correct. There is no RC book.
Yeah, then you can do the conversion without any hurdle. Wherever there is RC book, at the time the RC updation has to be there for
Yeah.
your bike, for your car and all, right? Then what is retrofitting? Retrofitting, Gaurav, is nothing but converting existing petrol diesel vehicles into electric by swapping the existing engine based powertrain through an electric powertrain. Right, what we do is we remove the engine, fuel tank and all, and we put electric motor, battery controller, charger into it. So I'm glad to share that we were the first startups in India to attempt retrofitting to convert vehicles into electric. Then any other question I'm able to see in chat box? How about maintenance costs related to battery life? That will be huge as compared to ICE engine. Yeah. So what happens is with respect to battery pack, okay, so there are so many safety aspects of the components, and there are so many warranty, guarantee, and multiple things given by the manufacturer. So presently, manufacturers are giving warranty of 3 years to 5 years to 10 years, depending on the make, model, and the things. So maintenance cost of battery, actually, as I said, operating electric vehicle needs awareness. You need awareness about how to utilize the vehicle, how to charge the vehicle, and all those things. If you are doing that thing with the proper guidelines given by the manufacturers, right, you will not be kind of impacting, or you will not be troubling the life of the battery. Okay. But what happens is, if you are not operating the vehicle properly, then deep discharge, then the battery life might get compromised. Okay. So with respect to battery maintenance, so battery maintenance nowadays, lithium ion batteries are there. So these batteries don't have much maintenance like the lead acid batteries and all those things. So they are having high energy density, high power density, and high energy to weight ratio, and they are more comfortable for EV application. You can see Tesla. Can you tell me, Tesla, which motor Tesla is using, AC or DC motor? Yes.
AC
Yes,
motor.
please. AC or DC?
AC
AC,
AC.
single phase or three phase?
No idea.
Yes, three-phase AC induction motor it is using, right? And then another thing is, yeah. So my point was telling that the maintenance cost of the battery will be as per the manufacturer and the model and the other things that you are actually using, right? So I hope this gives you a clarity to the battery maintenance question that you have asked, right? So
Ashar, there are few questions in the chat box, so I will take one by one. I'm Swapnil from
yeah, you can take
Happy Shah. Yeah.
instead of instead of me searching, you can take that.
Yes,
That's not
yes,
a
yes,
problem at
yes,
all.
yes, yes. I will be reading the questions for you, and you can just answer for them. So Anil Kumar
Definitely,
Bhatt has
definitely.
the question for you. Is there any? I mean, I think he means, is there any standardization for battery?
Yeah, standardization for battery is that presently there are different things get that goes into the battery pack. Okay, so what happens is, one thing is with respect to the cell. These cells will be connected in series and parallel to form a battery module, and these modules will be connected in series and parallel to form a battery pack. And this battery pack will be getting integrated with BMS, and that's how the whole the battery pack will be serving in the EV industry. So standards in the sense, you know, charging these battery packs needs different connectors. Okay, so standards, I mean, when you are talking about that thing, so we have to take consideration of those connector as well, since the battery will be inside the electrical system of an electric vehicle. Okay, that will not be coming in interface of the other part. The thing that will be coming will be the connector for charging, the connector, right? So that will be there. So in terms of standardization of battery, I can say presently in industry, many manufacturers are going for lithium based chemistry. Okay, in lithium also there are different chemistries. Okay, there was I hope you are aware about NMC, LFP, like that. There are different chemistries in lithium also. So presently, based on the applications, and based on the cost parameter, based on the life parameter, there are multiple chemistries that are like that manufacturers are choosing, right? LFP is very convenient, like taking the consideration of life and safety, right? So like that, there are different standardizations that are there presently in the battery chemistry. Then in terms of connector standardization, there are different connectors, right? One, like depending on whether you are charging using AC supply or DC supply. In charging, there are levels of charging: level 1 charging, level 2 charging, and then DC fast charging. In level 1 charging, what happens? There will be a voltage of system level 120 volt, in the level 2 240 volt, and more than 480 volt will be there for a DC fast charging. So there, depending on that, connectors are there. For example, J1772 connector, then combo connector, GB by T, it is a Chinese connector, then CHEDEMO connector. So like that, different connection standards are there. So as of now, these things are there with respect to the different standardizations that happens in battery chemistry or the connectors part.
Thank you, Ashar. Next question from Ankit Gujarati. Sir, the battery replacement cost of EV is very high. It's the main concern in customer mind. Can you give some insights?
Yes, so battery cost is definitely high, and that is, I will tell you, 60% of the cost goes in the battery only. 60% of your electric car cost goes in battery only, right? So, but you see, you have to do a bit of research and understand every year the cost of lithium is decreasing, right? Every year the cost of lithium is decreasing. So, what happens is in coming days, the cost of electric vehicle battery will be affordable. Why means you see the demographics and you see the statistic, you will come to this conclusion that electric vehicles are going to be the future, and there are different energy storage solutions and energy storage devices that are also under development. So in coming days, the cost of electric vehicle will come in terms of affordable, and the battery cost, as I said, the lithium cost is decreasing every year. If you see the graph, right? So this battery will become affordable. And another part, you see, if you do a quick calculation with respect to the operational economics and money that you are investing in your electric car, and if you can consider a diesel car or a petrol car, then you will come to understand, you do the whole calculation, the operational economics, the maintenance calculation, as well as the capital investment that you are doing. You will come to the conclusion that the TCO for a new electric vehicle is definitely favorable for a particular customer. I will tell you what happens 5 years, 10 years back, when people were heading towards installing solar rooftop systems at my home. I also have a solar rooftop system at my home, investing 1.8 lakh rupees for a 3 kilowatt a system. So now I'm able to, I'm paying only 30 rupees, 50 rupees as my electricity bill to the Maharashtra State Electricity Board, right? So you see, that is how the initial concern will be. But as I said, that is why awareness is needed. That is why Gauravji, awareness is needed. We are trying our best how we can aware more and more people in terms of electric vehicle, and that is how EV for India we started with the whole intention, kind of create more and more awareness to the people. And for that purpose, we are conducting free webinars, we are conducting kind of electric vehicle exhibitions, we are conducting plantation drives and multiple things in order to make sure that all people are getting awareness about electric vehicle. And whenever you find time, you can definitely visit this channel. I'll share you the link for the YouTube channel that we have for Skillshark. Okay, there you can find multiple innovations, right? Like that will make a bit of, like, a bit clarity in your mind with respect to the question that you ask, right? So with respect to the different EV projects that students have done, multiple innovations that students have done, so this will be giving a bit clarity to the question, right? So I will share this thing here in the chat box. Yeah, yes, please.
Yes, Ashar. Next question is from Dr. Swanan. During retrofitting of Alto 800, what care required to use same gearbox? Dr. Swanan, the question is.
Same question is there. Actually, during retrofitting of Maruti 800, if same system we are using, whatever presently available, if we remove the clutch plate and the remaining things, and if we want to give the drive to the gearbox directly, whether conventional motor system is sufficient or something else is required.
Right. So when we talk about retrofitting, converting existing vehicle into electric, okay, when we are going through that approach, the first thing that we have to do is remove the engine part, and engine part in the sense, remove the engine and remove the fuel tank part. Okay. Now when we are putting the electric powertrain into it, we can do it, by making it front wheel drive or a rear wheel drive. Rear wheel drive we are making means we have to have an axle of particular dimension suiting the rear axle of the vehicle, then we should have a differential and the gearbox and the motor that we can fit in the rear, and we can make the vehicle electric. We can retrofit it into electric. Another approach is making the vehicle front wheel drive. In the front wheel drive, what we can do is we can simply remove the engine. Okay, remove the engine, make a coupling that is suitable for the motor and the existing gearbox. We can make a coupling like that, and once that coupling is there, we can easily transmit the power from whatever motor shaft to the gearbox. So like that, people have done retrofitting. People have done multiple attempts in retrofitting in these ways. So both of these are possible and feasible.
Whether there is the things with because with the splines we are connecting and electrical motor to this particular gearbox, when motion will get transmitted, whether there will be the chances of failure of these splines or etc.
For that purpose, spline and whatever coupling we are making, okay, we have to first see the splines and we have to see the structure of the existing gearbox. Okay, after studying that, we have to design a particular coupling for it and go for a rigid manufacturing, right, without compromising the material of the coupling and all those things. If that is clear, means we will be able to like the coupling will be able to bear the load transmission and this part. That's not a big problem, but one thing we have to ensure that the speed, torque and other parameters has to be decided. If you don't want to go for that particular speed or results or particular output that you are getting by front wheel drive, then you can switch to rear wheel drive, or you can make a new gearbox and you can utilize that.
Okay, sir. Okay.
Next question from Shubha ma'am. She is asking that lithium ion or lithium phosphate, which is better?
Yeah, so lithium ion, lithium phosphate, like that, people cannot tell this is better, that is better. What happens is, one second, we have a course, you can definitely kind of check it. This course we are executing in association with Automotive Skill Development Council. Okay, that is with respect to electric vehicle safety, EV safety fundamentals. So in that we have covered multiple aspects of these type of things. But one second, I will share you a slide from it to make you understand. Okay, what is the difference and what actually goes into consideration. I hope you are able to see my screen. Right?
Yes, yes, sir.
So what happens is there are different chemistries: LFP, LMO, LCO, NCA, NMC. Right? I hope you are aware about all these things. Lithium, manganese oxide, cobalt oxide. Right? So there are different chemistries. Now there are various parameters that decides which one is better for which application. So now if I want to go for higher life and higher safety with affordable budget, I can go for LFP. LMO will life will be less, safety will be medium, and the cost will be low. Okay, if I want to go for a low cost Jugaad, then LMO, people might find the LMO useful. NMC is having high life and high cost, but safety is medium. Okay, so now it's upon us, okay, with respect to what kind of quality or what kind of application we are actually moving in, and based on that we can decide. Hope this clarifies the question.
Yes, the next question is from Mr. Jeena. Battery management is most important in EV. Can you suggest some companies who are dealing with battery cooling system, online data logging?
Yes. So what happens is, when we talk about, hello, am I audible?
Yes, yes, Ashar. Yes.
Yes. So when we talk about, a particular thing with respect to BMS is very, very important. BMS is very, very important, and not only for charging, discharging, the balancing of the cell, and multiple other things, right? Multiple other things that will be there. The thermal management, the temperature thing, and other things. So there are different BMS that are there. There are different BMS. Have you heard about Orion BMS? Orion BMS, there's a company called Orion that they manufacture their BMS. Okay, so Orion BMS is there. Then apart from that, there are multiple other BMS companies. Okay, so what they do, they particularly manufacture BMS, and that will be having compatibility, and that will be having thing that can be actually integrated with multiple things. For example, let me tell you, when we have different types of cells, right, from LFP to NMC, so not only the cell chemistry, the cell dimension will also vary, right? Prismatic cells will be there, cylindrical cells will be there, pouch cells will be there. So for managing multiple kind of capacities of the cell, multiple chemistries of the cell, and multiple voltages of the cell module and the entire battery pack. So BMS has to be equipped with smart functionalities like balancing, like the thermal management, data acquisition, right, and all those things. So for that, different companies are there. As I said, Orion BMS is there, then ISR BMS is there, then EMUS BMS is there. So like that, different companies are there, those who are making their own BMS. So you can definitely explore about these companies and their product. And apart from that, every electric vehicle battery manufacturer will be trying their best in order to equip their battery pack with this data logging facility, with this BMS, with thermal management and multiple other things. So thermal management work is heavily going on in the thermal management region. Why is presently the battery pack that are used in electric vehicle in India are 36 volt, 48 volt, 60 volt, 72 volt, 96 volt, like that. So till this 96 or 60 volt, thermal management was not too needed at all, but definitely thermal management is needed. Now when we are going for higher voltage of 96 volt and more than that, people are now working on heavily on the thermal management system also.
Yeah. Thank you, Ashar. One interesting question from Mr. Gaurav. Sir, for how many hours you work?
Gaurav, this is a bit tricky thing. What we do,
Sir,
I'll
I
tell
am
you.
expecting a real answer from your side, because the
No.
knowledge and the information, everything which you have shared, it is really helpful for us, for everyone.
So thanks a lot, Gauravji. Thanks for your kind mention. So we usually take rest. Whatever daily chores we have, like eating and taking, whatever needs are there. Our major contribution goes for this technological development, because we believe that, I'll tell you a simple thing. In India, unemployment is not a problem at all. In India, unemployability is a key problem. We don't have employability skills. And there are simple four things that we need to connect: skills, innovations, employability, and entrepreneurship. If our students, if our faculties are working on skills, these skills should lead to employability. And if they are working on innovations, this innovation should lead them to entrepreneurship. So this is a clear thing that we have in our mind. So, and I'm glad that we are working on EV technology from 2014, and these exploration only kind of given this opportunity to understand. And you will be surprised to know I'm just 24 years old, and so all these exploration. Yeah. Thanks a lot, Gaurav. Thanks a lot. Yeah.
Thank you, Ashar. I think we already crossed the time limit. So we will just move to the vote of thanks proposed by Mr. U.A. Nikam, sir.
Definitely, sir. Definitely. Yeah.
Nikam sir, voice.
Nikam sir,
Yes.
your voice is a little bit low.
Hello.
Yes, yes.
Yeah. So thank you, Ashar sir, for such a wonderful interactive session. Initially, you have cleared the concepts of operational economics and ecosystem from India's point of view. You have nicely elaborated EV system and subsystems of hybrid vehicles while delivering your topic. You have thrown light on India's automotive future, its challenges and future employment possibilities through electric vehicle. I must say thanks to the participants also for their enthusiastic response during the session. Thank you all for this wonderful session. Here, I would like to say that the first session of today is concluded, and we shall meet for next session by 12 p.m. today. Thank you all. Thank you.
Sir, it's request to all the participants. Please turn on your video.
Yes, there are two requests. One is to turn on your videos, and the feedback link is already posted in the chat box. So kindly fill the feedback.
Please, it's a humble request. Please, all of you, turn on your video.
Amit sir, do let us know when you're done.
Yes, sir, sure. Sir. Just wait for 1 minute. Yes, sir, done.
Thank you, everybody. We will start with the session 2 at 12 noon. So see you there. So thank you, Ashar. And thanks to all the participants.
Thank you, sir. Thanks a lot. Thanks a lot for all the participants for their patience, and thank you APSIT for the opportunity. Would love to contribute in best possible way for fostering skills, innovations, employability, and entrepreneurship in any possible way. So presently, Skillshark is working with more than 250 plus institutions in India and Africa for multiple propositions of upskilling, skill development, center of excellence, and all. Any contribution from our end, we would be glad to be to contribute. Thank you.
Sure, sir.
Everyone requested to do the, please fill the feedback form without fail.